I hope that you are in a good condition and also you're healthy. It's good. And in this video, we're going to continue with our module 5, and this is under 5.3 part B. So this is the continuous for your 5.3 videos. Last video is 5.3 part E, and now it is part B. What we're going to cover, okay, first of all, we're going to see the interrupt cycle. After this, you're going to see there is several type of interrupt in terms of the short delay and a long delay also. And now, let's take a look what is in our interrupt cycle. All computers provide a way of interrupting the fetch, decode, execute. So normally, this is the normal cycle. Last time, right, you have learned fetch, execute, and sometimes you need to have to enable the interrupt and complete one cycle. Interrupt can be occur. Interrupt occur when, so there is 3 conditions. First is a user break. Whenever you have your source code and then you try to debug, or maybe you step by step looking into the output, and you click in your keyboard Control CTRL, isn't it? And with following the C, then you're going to stop, which is interrupt happen. Second is input output is required by the user or a program. If let's say in your program asking for a user, for you to key in something in your keyboard, as the input. So it requests, So you're going to stop first. Maybe it's just a wait for a while, or maybe totally interrupt and restart your programming, as depend on your programming. And lastly, a critical error occur, whether your programming's got error, or maybe your laptop suddenly sleep or run out of battery, turn off by itself. Then you're going to have the interrupt cycle. Interrupt can be caused by hardware or software. Your hardware is your keyboard. Your mouse also can be has a hardware, and for your software, your source code. Maybe your source code got error. It depends. So software interrupt are also called as traps. If software, it have a unique name, which is traps. Okay, now we move to next slide. What happened under modify instruction cycle to check for interrupt? Interrupt processing involve adding another step to fetch, decode, execute cycle as below. So there will be an option whether has an interrupt been issued or not. If yes, you're going to process the interrupt. If no, what you need to do is you need to perform fetch, decode, execute cycle. So this is what you need to do before you proceed to your loop or your next instructions. So this is going to be an option in the cycle, the normal cycle, when you added the instruction cycle. So here will be some of example, not example, but the explanation in terms of diagram. You can see basically what is happening inside your CPU and also your data, your bus system and your memory. So you have these three elements are connected to each other. So the flow, the current content of PC must be saved so that the processor can resume normal activity after the interrupts. Similar also if let's say you are using your Microsoft Word. If suddenly there is an error, so your laptop is running out battery, it's automatically turned off, you will notice that you will have a temporary file which is you save into your processor, although you are not the one that key in the button save. So we see the flow. Okay, first of all, the first step is the current content of PC must be saved to come back after interrupt. So you can see from your PC where it's going to go. The contents of PC is transferred to your MBR, your memory, then place it into your data bus. Okay, from here it's going to be sent to your MBR. So you just place it here, and from your MBR for second this one from your step number 1, and then after that for step number 2, you're going to store inside your data bus. So you're going to store here, and if let's say you restart your Microsoft Word, you're going to have the file inside your database, and you can just transport it back. Okay, this is what happened when there is instructions. And third, the special place in memory to keep this is given by CU, which is your control unit to MAR. Then place at the address bus. So what happened? You will do that. The control unit will interrupt and also give instruction to your MAR. Then the value or the file or whatever that you are interrupt with will going to place into your address bus. After that, step number 4, when you place it into your address bus, because this is the address, you need to store, because this is the address bus, you need to store it into your memory. Keep it in a stack. Whatever value, whatever that you interrupt, you're going to store inside your memory.
It's 15 hours.
Fifth PC is loaded with the address of the instruction routine. So then you're going, let's say now it's at the address of 100, and you have the value of 1 hexadecimal, let's say, you store inside your memory. And whenever you load your PC, then you're going to have your initial value, which is 100, and then when you do updating, maybe it will increase. But after all, whatever that you are sending to your address bus, this will be the updated versions, which is your PC will loaded it with the address of the interrupt. count routing. Okay, we're going to move to our interrupt. So for our interrupt, you can see over here. Virtually, a computer provide a mechanism. You can see computer provide a mechanism by which other module, which is your input output or your memory, may interrupt the normal processing of the processor. This one is already, because sometimes you can interrupt whatever process that happen inside your computer. Interrupt let CPU execute its normal instruction sequence and pause. You're going to stop it to service the external devices only when they signal the interrupts, which is the signal, that they are ready for the CPU attention. So this is what we're going to happen when you are having instructions in your computer, whether it is under software or maybe in a hardware. You have two kind of interruptions. So we're going to move to another. Now you're going to see there are like flow. Is it? Program flow of control without and with interrupt. There are a lot of error. You can see too many error also. Maybe you feel like, wow, what is this? It might confuse you. But we're going to see it one by one. Let's take a look what is basically happen. First, we're going to see no interrupt. What is happen in the no interrupt? When you have no interrupt, what will happen? The flow basically. So inside this flow, you can see you have user program, and then inside of this you have the writing, whatever that you are writing, the codes and all. So you can see this is first step. When you have this one, maybe you can have you are running your program. What happened is maybe there is an instructions, but in this flow there is no instructions. That's why you're going to follow exactly what is normal flow it is. Then you're going to move to your input output program under the command, and then you end your programming over here, and you're going to go back to your code writing. You're going to continue, and then it's going to back and do similar thing, follow and doing a loop, and then same to the third. And if let's say you have this third and you might also have like this and etc., it's going to be continuous basically. So this is the normal this is the normal flow for no interrupt. And B, if you have an instruction, so you can see over here, your flow first under your user program. So this is your program. Then you're going to go to your input output program, of course the command. But before you end it, you're going to see that interrupt occur during a course of execution of user program. So you're going to go to the interrupt because there is an interrupt. Then you need to handle the interrupt until you end the process. This is basically one of your process of your executions, and you go back to your programming user program. After that, maybe that will be also occur some things, the next instruction and so on. You're going to go back to the flow, and then there is an instruction and so on. And this one is only a short input output wait. So this one is short input output wait. And what is the difference between this instruction and also interrupt with a long input output wait? So you can see over here, the difference only at this section. So you can see over here. Rarely you cannot see, let's say there is an interrupt occur, but this is a long input output wait because you're going to wait whether it is having the instruction or not. So it's going to be a long rather than if you see this one is a short. You have a short and you have interrupt and you will continue. But this one you will continue it all, and basically there is a interruptions. And of course after having an interruption, you're going to do the instruction handle. That is the difference. Now you're going to see what is happen one by one. To appreciate the gain in efficiency, consider the timing diagram based on the flow of control in previous figures. So you're going to see the flow depend on your previous figure over here. You can see there is a green color, but basically I cannot see it as a green, but yeah, assuming this one is a green color, shaded green. Which is the shaded green is the user program or code segments. While for input output program, the color will be a shaded gray. And for the black is the input output operation, as similar as the processor width. So this is the flow without instruction. So you can see after your program, you're going to execute to the fourth step, which is your input output process. First, you're going to see your user program, and then after that you go to your input output program, then your input output operation will be doing here. After you have done, Allahu Akbar, okay. After you have done with your input output command and so on, you're going to go to the step number 5. You're going to go to the step number 5 until you end. You do the input output program. After that, you go to the input output command and you end. After you end, you're going to go back to your step number 2, which is under your user program. See the green shaded green color user program, and you're going to continue. Basically, it's going to continue the looping. Okay. Now you're going to see program timing for your short input output wait. Over here you can see input output operation concurrent with processor executing. This one is representation with the instructions of this. It is similar only in the different presentations. First, you're going to use to go to your user program as well, similar to here, and you're going to go to the input output. Input output, you will do. You can see after you have done the input output, you're going to go back to your user program before you end, because you're going to have the instruction later on. See, that's why you go back to your 2A. When you are having 2A, you're going to have an instruction. It will continue later on, so it is a short period only. After your instruction, you're going to do the 2B. Then it's going to go back to your input output. What will happen? Your input output will process the instruction. See over here, you're going to do the instruction handle until you end everything, and you're going to have an instructions again. Then you go back to the user program for 3A and 3B. This one is a short wait, so you can see there is a part by part, because you're going to divide it into several. In one, let's say you have step 2, but you need to divide it into smaller with, which is you wait a small part first, and then you have instruction, and you continue with another part B. And over here you can see it is a program timing long input output wait. This one is similar without instruction, and you can see you start with step number 1, similar to whatever happened here. User program, after that you will go to your input output program, step 4, until your input output command, but you're going to go back to your user program for your source code, and this is going to be one process, which is process B. See over here. Then you're going to have an instructions, because this is a with interrupt. After you have done the interruption, a cure in instruction, you're going to settle your instruction. But before you're going to settle, of course, you're going to handle your instruction until finish. Then you go back your user program again. So this is the flow. You go to the input output instructions, and after you finish, you're going to go back to your user program. So it's going to continue if you have the next instruction, and so on. So this one is the detail or descriptions about your program, timer, input output, or hardware failure. So program is generated by some condition that occur as a result of an instruction execution, such as arithmetic overflow, division by 0, attempt to execute an illegal machine instruction, or reference outside a user allowed memory space. While for timer, generated by a timer with the processor. This allows the operation system to perform certain functions on a regular basis. Generated by input-output controller to signal normal completions of an operation. Request service from the processor or to signal a variety of error conditions. And lastly, the descriptions for hardware failure generated by a failure such as power failure or memory parity error. And this is the summary for your 5.3, which is your summary 1. The major components of computer system okay, this one is I think all in your summary module 5, but from 5.1 until 5.3 you summarize it. You can see you have control unit, register, memory, ALU and data path. This is the major component for your computer system. Computer run program through iterative fetch, decode, execute cycle. So this is the standard cycle for your computer. Summarize the instruction cycle. Distinguish between user visibles and control or status registers, and discuss the purpose of registers in each category. So you try to conclude it by yourself. Okay, I'm going to stop this video until this part only. Later on, we're going to meet again in our next video 5.4. We're going to look into instruction pipeline. Thank you for your watching, and please make sure be careful and stay safe. Bye bye.